Hello and welcome to the third lecture in electricity. So here in this lecture we shall deal with Ohm's law, which is very important. So if you have missed watching the remaining two videos, make sure that you go through that. We have dealt with what is electric current, electric circuit in the first video. In the second video we have also dealt with electric potential and potential difference. Now what is Ohm's law? So Ohm happens to be a German scientist, a physicist. In 1827, he observed an important relation between current and voltage. Now let us consider this circuit. So we have current which is flowing from the positive terminal to the negative terminal. So I have current I, resistance R, and to measure the voltage between the resistor I have connected a voltmeter. There is an ammeter connected in series which will measure the current flowing, and the switch is closed. So he observed that with increase in current, the voltage across the resistance also increases. So therefore, as the current increases flowing through the resistor, what happens? The voltage also starts increasing. So this is a relationship what he observed, that is the relation between current and voltage, of course with the temperature being constant. So he observed that the voltage is directly proportional to the current I if the temperature T is constant. So if I remove this proportionality, so V equals some constant into I. So this constant, so if I bring I to the denominator, this constant is referred to as R, which happens to be the resistance, or V equals I into R, right? So what is R? R is a constant, resistance is a constant for a given metallic wire and for a given temperature, right? So it is the property of the conductor to resist the flow of charges through it. So charges have to flow through a conductor, and the conductor will not allow the charges to flow through it, and there will be some resistance. So the resistance offered by any device, may be a conductor or any given material, for the flow of charges through it is referred to as resistance, and that resistance is given by V by I, where the voltage is always directly proportional to the current. So therefore, how do I define the resistance? So this resistance R is measured in terms of ohm, and this is the symbol. So when do I say that R is equal to 1 ohm? So R is equal to 1 ohm when the voltage is 1 volt and the current is 1 ampere. So the resistance is 1 ohm if the voltage is 1 volt and current is 1 ampere. So if the potential difference between any 2 points of an electric circuit is 1 volt and if the current flowing through it is 1 ampere, then we say that the resistance R of the conductor is 1 ohm. So let me repeat. Between 2 points, if the voltage between the 2 points of any given conductor is 1 volt and if the current flowing through the conductor is 1 ampere, then the resistance of the given conductor is 1 ohm. So next, what do we observe? We find that the resistance is inversely proportional to I. That means as current increases, the resistance definitely has to reduce. So therefore, if I reduce the resistance, so if I use a given material, of course the resistance remains constant. But if I use a variable resistance, so if I use a variable resistance, so we have seen that in the previous video, a variable resistance or a rheostat is a device where the resistance can be varied. So if I connect a variable resistance to a voltage supply or to a battery, so if I connect a variable resistance to a battery, as the resistance reduces, what happens? The current I increases. So they are inversely proportional. Whereas if the resistance increases, the current I reduces. So let's take a very simple example. If the voltage is 10 volts and if R is 1, so V is 10 volts, R is 1 ohm, what is I? I equals V by R. So from this expression, I equals V by R. So it is 10 by 1, which is 10 amperes. But if R equals 10 ohms, so let me assume that I am increasing the resistance and it becomes 10. So therefore what is I? I is 10 by 10, V is 10, R is 10, I have 1 ampere. So as the resistance increases, current reduces. But as the resistance reduces, current increases. So we find that the resistance is inversely proportional to the current. So now we need to know what are the various factors affecting resistance of a conductor. So we have defined what is resistance, and resistance for a given conductor remains constant at a given temperature. But what are the factors affecting resistance of a conductor? So let's see that. So section 12.5, what are the various factors affecting resistance of a conductor? The first happens to be the length of the conductor. The second one happens to be the cross-sectional area. So area of cross-section. And the third one, of course, happens to be the nature of the material. So the factors affecting resistance depends on these three. One is the length, the other one is area of cross-section, and the third thing, of course, happens to be the nature of the material. So if I use a different material, its resistance will be different. We find that the resistance is directly proportional to the length. That means as the length increases, the resistance increases. It's like saying that if the road is longer, then I have to travel a longer distance. So I have to expend or spend more energy, right? So it's something similar to that. So if the current has to move through the conductor for say a given length L1 and then for a given length say L2. So if current has to flow through L1, then of course the resistance will be less because it travels a shorter distance. But if the charges have to move through a longer distance, definitely resistance will be much larger. So the resistance is directly proportional to length L, but the resistance is inversely proportional to the area of cross section. But if the area increases, what happens? There is more room for the charges to flow, isn't it? So therefore the resistance reduces if the area increases. So therefore I have these two. So R is proportional to L by A. So if I remove the proportionality and put an equal to sign, I have a constant. That constant is expressed by using this symbol, which is known as rho, into L by A. Now this rho is referred to as the electrical resistivity of the material. So this is nothing but the electrical resistivity. So what about the resistivity of conductors? So metals are usually good conductors, metals, alloys. So the resistivity is around 10 power minus 8 ohm meter to 10 power minus 6 ohm meter. So these are usually good conductors. So we find that the resistivity is very low. Right? 10 power minus 8 means what? 1 divided by 10 power 8 to 1 divided by 10 power 6. So it's very low. The resistivity is low. So therefore metals and alloys are very, very good conductors. But what about say rubber, glass? They are all called as insulators because they do not conduct electricity or heat. So therefore their resistivity is very high, say 10 power 12 ohm meter to 10 power 17 ohm meter. So these are referred to as insulators. So what are insulators? Insulators are essentially devices which do not allow the flow of charges through them. So therefore they are bad conductors of heat and electricity. Why is that so? Because their resistivity is very high. 10 power 12 to 10 power 17, and whereas 1 by 10 power 8 to 1 by 10 power 6. So you find that there's a huge difference in the resistivity. So therefore these are good conductors and these are termed as insulators. So now let us go through the examples and the questions given in your textbook. So example 12.3, which states that how much current will a bulb draw from 220 volts if the resistance of the filament is 1200 ohms, and 2, how much will an electric heater draw current from a 220 volt supply if the heater coil is 100 ohms. So we find that there are two different devices, and here in the first case the bulb filament has a very high resistance. So what about the current for the first one? We know that V by I equals R, or I equals V by R if I interchange these two. So therefore for the first case V is 220 divided by resistance is 1200. So therefore the current is 0.18 amperes. But whereas the second one, V is 220, but what about the resistance? It has dropped down to 100. So therefore the current is 2.2 amperes. So we realize that as resistance increases, current reduces. If resistance reduces, current increases. So that is why we mentioned that the current is inversely proportional to the resistance. We have seen that. Next, example 12.4. The potential difference between the terminals of an electric heater is 60 volts. So V equals 60. It draws a current of 4 amperes from the source. So now the question is, what current will the heater draw if the potential difference is 120 volts? So there is an electric heater. So this is a heater, and the potential difference across the electric heater is 60 volts. And what is the current which it draws? It is 4 amperes. So this is the current I which it draws. So now let us try to find the resistance. What is resistance of the heater? So R equals V by I, which is 60 by 4, which is equal to 15 ohms. So the resistance of the heater is 15. So therefore this is the heater having a resistance equal to 15, and then I have a potential difference of 120 across the two terminals of the battery. So now what is the current drawn if the potential difference is 120? If the potential difference is 120, then current I equals 120 by 15, it is equal to 8 amperes. Right? So here in the second part it's been mentioned that if the potential difference is 120, find the current. So it is 120 by 15, which is 8. Because the resistance of the heater does not change. The resistance of the heater remains the same. So in the first case it was drawing 4 amperes. So we did find the resistance using the resistance value. Now if the potential difference across the heater is 120, so we have connected an electric cell or a battery of voltage 120. So now what is the current? The current would be 8 amperes. So example 12.5, the resistance of 1 meter of wire is 26 ohms at 20 degrees Celsius. If the diameter of the wire, so the diameter D of the wire is 0.3 millimeter, find the resistivity and also find the material. So we have to use the table which is being given in your textbook to find the material. So we know that the resistance R is nothing but rho L by A. So what is R? R is 26 equals rho into L is 1 divided by area. So area of cross section. So it is nothing but pi r square, isn't it? So pi into r is d by 2. So 0.15 millimeter, or it is nothing but 0.15 into 10 power minus 3 meters. Because I'm converting millimeter to meter, because this is in meter, so I have to convert the radius into meter also. So it is 0.15 into 10 power minus 3 the whole square, because this is pi r square, where r happens to be the radius. So you know that the radius of the wire is r. If the radius of the wire is r, then the area of cross section is pi r square. So now what is rho? Rho is equal to 26 into pi into 0.15 into 10 power minus 3 the whole square, and if we do find the value, we get 1.84 into 10 power minus 6 ohm meter. How is it ohm meter? Area is meter square, so let me write rho as R into A by L. Resistance is in ohms, area is in meter square, and what about length L? It is in meters. So therefore the unit of resistivity is ohm meter. Now from the table we find that 1.84 into 10 power minus 6 is manganese. So therefore the material is manganese. Next, example 12.6. So now let's go through problem 12.6, a very interesting one. A wire of length L and area A has a resistance of 4 ohms. So let me call this as R1 equals 4 ohm. So we know that R1 is nothing but rho into L by A, and this is equal to 4 ohms. So now the next part of the question is, what will be the resistance of another wire of the same material? So material is the same, but if the length is L by 2 and if the area is 2A. So therefore, let me call that new resistance as R2 equals rho into length is L by 2 and area is 2A. So I have rho L by A into 4. But what is rho L by A? It is nothing but R1. So I have R1 by 4. What is R1? R1 is 4 ohms. So I write it as 4 by 4, which is 1 ohm. So therefore R2 is 1 ohm. Very simple problem. It looks complicated, but the problem is very simple. So now let us go through a few questions which has been given after 12.5. The first question, on what factors does the resistance of a conductor depend on? It definitely depends on the length, it depends on the area of cross section, it depends on the temperature, and definitely depends on the nature of the material. So therefore the resistance of any given conductor depends on all these 4 factors. 2. Will current flow easily through a thick wire of the same material or through a thin wire? So will it be thick wire, or the question is it going to be a thin wire? So we know that the resistance equals rho L by A. We have seen that the resistance is directly proportional to length but is inversely proportional to the area. So therefore, if the area is much larger, that means if the wire is much more thicker, then the resistance will reduce, so therefore the current will flow much more easily. So the answer is thick wire. So the current will flow much more easily if the wire is thick than when the wire is thin. The third question, the resistance remaining the same while the potential difference between the two components is reduced to half. So the potential difference is reduced to half, that means it has become V by 2. what change will occur in the current. So the question is, what change will occur in the current? So let's assume that V equals I1 into R. So resistance is R, voltage is V, so the current is I1. So now what has happened? The resistance is the same, but voltage has become half. So I have V by 2 equals some other current I2 into R. So here, what is I1? I1 is V by R. So similarly here, what is I2? I2 is V by R into 1 by 2 equals I2. So what is V by R? V by R is I1. So I1 by 2 equals I2. So what has happened to the current? So the current I2, which is the new current here, is nothing but the original current I1, which is reduced by 2. So therefore, the answer is when the voltage is halved, the current also reduces by 2. If the voltage is reduced by 2, then the current also is reduced by 2. So that is what we have shown. Fourth one, why the coils of any electric device made up of alloy when compared to pure metals? Because alloys have very high resistivity and hence the melting point is much more higher. So most of the electric coils and electric heaters are made up of alloys. So the fourth question is, why are coils of electric irons and heaters made up of alloys when compared to pure metals? Because they are very good conductors of heat and electricity and they have a very high melting point. So we do not want the metal to melt in an electric iron or a heater. So they have very high melting point and they are very good conductors of heat and electricity, and that's the reason why alloys are used. 5. Use the table. A is iron or mercury better conductor? So from the table we find that iron has a lower resistivity, so therefore iron is the better conductor because it has a lower resistivity compared to that of mercury. And B, which is the best conductor? We find that silver is the best conductor from the table. Why is that so? Because it has the lowest resistivity. The resistivity of silver is the lowest, which is 1.6 into 10 power minus 8 ohmeter. Right? So as the resistivity reduces, what happens? The conductivity goes on increasing. So therefore we find that the silver is the best conductor. Right? So in this lecture we have gone through Ohm's law, we have solved a number of problems, and also we have understood what is resistance and what is resistivity, what are the factors on which the resistance of any given material depends on, and we have seen a few problems. So in the next video segment we shall see what happens when we connect resistors in series, and then later what happens if resistors are connected in parallel, what happens to their equivalent resistance. So all those things we shall discuss in the next video segment. Do not forget to like, share and subscribe, and you can join the Telegram group which is being given in the description to get regular updates of all posts on 10th Maths and Science. And do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads, and also go through the playlist Maths for 10th to view all the lectures and solve problems in mathematics for 10th. And thanks for watching.